Alright, well let's wrap it up here with the last few problems here. Now you're still solving uh, radical expressions and or equations that have rational exponents. The only difference is that sometimes you might get some extraneous solutions, so it is very, very important to check your work. And then just like the previous problems that we've been doing, it's very, very important that we isolate that radical first. So looking at A, what's our first move with A? See how that minus 7's outside the radical? We got to add 7 to both sides. Got to do that first. So when we do that first, here's our expression now, or equation now, I'm sorry, is the square root of x of 3x plus 31 equals x plus 7. Now that we have the radical isolated, to undo the square root, what we have to do now is square both sides. Look how we very carefully square both sides. When you square the left side, it just undoes the square root, so we're left with 3x plus 31. When you have the right side over there, you have to square x plus 7 squared. I can't tell you how many times I have to correct students and mark it wrong when they try to tell me that x, boy, that looks very Nazi-ish. I don't want to do that. It looks very swastika-ish. So I'll just write it right over here. X plus 7. I can't tell you how often I have to correct students and say, no, it is not x squared plus 49. Okay? What they are forgetting is that when you are doing x plus 7, you are doing x plus 7 times a second x plus 7, which means you have x squared plus 7x plus a second 7x plus 49. Oops, not 44, 49. So let's make sure that we realize that when you square a binomial, you are going to have like terms right there in the middle, and those would combine together to give us the correct squared of x, perfect square trinomial of x squared plus 14x plus 49. Now here comes the next move. Because this is now a quadratic, your objective when it comes to solving a quadratic is setting the quadratic equal to 0 and then using methods such as the quadratic formula or factoring, wink, wink, nudge, nudge. So to set up the factor job here, let's go ahead and subtract 3x from the 14x, and let's subtract 31 from the 49. Does that make sense? So that way now we can set the left side equal to 0. So then now we have 0 being equal to x squared plus 11x plus 18 when we subtract that 31. So now, factor, can you come up with two numbers that when you multiply them together you get 18, and then those same two numbers add up to 11? I think we can do it. 18 is 9 times 2, and 9 plus 2 would give us 11. So we can factor that. Moving that way up here, what I just did there was the zero product property, right? X plus 9 could be equal to 0, or x plus 2 could be equal to 0. And that leads us to two solutions here. X could be negative 9 because I subtracted 9 from both sides, or x could be equal to negative 2. Now, let me give you a very, very important thing to do. You have to check for extraneous solutions. Wink, wink, nudge, nudge. One of these answers actually does not solve the original problem here. Let me erase those plus 7s. Okay? One of those, two solutions here, the negative 9 or the negative 2, will not give us a true statement here, a true equivalency. Here's how I would suggest that you do it. Why don't you just make the calculator do it? Let's go ahead and grab the calculator and check the negative 9. So we're going to substitute negative 9 and do the square root of 3 times negative 9 plus 31 minus 7 and see if it's equal to, see that's an x right there? If we do this right, we should get negative 9 back. We plug in a negative 9, we should get out a negative 9. Okay? And you actually can do this in all one big bite if you really wanted to. Just be very careful how you type it in. It would be 3, and I forgot already the rest of it. Oh, times negative 9 plus 31, then we got to close the square root. So do you see how I'm very carefully typing in the negative 9, close the parenthesis, I forgot the number already, how great is Mr. Cook's memory right now, plus 31. Okay, so then plus 31 Do you see this is the move that burns, students? You got to close that square root. See what I did right there? And then I believe, forgot already, minus 7. Okay? Now if this really is a good answer, what answer should I get when I'm done with this? It should give me negative 9 when I'm done with this work. Okay, oops, wrong button. Pressing enter. I got negative 5. Interesting. I don't think this is a good answer. So, what that tells me is that negative 9, you are an extraneous solution. I'm looking up at the top so I spell it right. So what I want you to do with extraneous solutions is I want you to eliminate them. Cross them off just like that. Okay? Now, if you're mega lazy like me, you can check the other one just to make sure you didn't make a mistake. It's still a good idea to do it. You should do it. Is just hit second and then press enter. Because then it can just copy in that same thing. Except now we're going to change that negative 9. Just type over the top, put a 2 right there. And if this works, should I get negative 9? No. Remember, what you put in is what you should get out. So if I put in a negative 2, if negative 2 is a legit answer, I should get negative 2 and I'm done with it. And take a look. Sure enough, look, I got negative 2. Okay? So that's what I kind of had covered up right here. That's me just checking the calculator, and I just do them both at the same time. Okay? And so what this is telling me here is that when I plugged in this, that's bad, which leads to the extraneous solution. But when we did this, we plugged in the negative 2 and we got the negative 2. That's good. So that means our only answer here is negative 2. Okay? So now we're ready to move on to the next one. What do you notice about the next one that might make the first step not needed here? Remember the first step over here? Wasn't the first step adding 7? Do you see how we don't have to even add 7 here? Do you see that the square root is already isolated? So now we're ready to square both sides. I'll have you guys square both sides and work that problem and check your work. Alright, take a look at this problem down here. So now I have two quantities being raised to, whoa, look at that, that's interesting. I have two quantities being raised to the exact same power. Okay? Interesting thought here. Let me put it to you this way. Well, first, let me show you the textbook way. Here's what the textbook wants you to do. Here's what every math teacher in the world wants you to do. What every math teacher in the world wants you to do is they want you to raise both sides to the same power, and I kind of misspoke here a little bit. So what I want you to do there is if you're being raised to a rational exponent like, say, 1/4, you actually want to raise it to, pardon me if I abbreviate here, the reciprocal power. Okay? So that's what every math textbook wants you to do. So in this case right here, since it's both 1/4, I'm going to raise both of these two sides of the equation to the 4th power. And then using my power of a power property, I could multiply those two exponents together. That would give me 4/4, which would be 1, right? So I'd have negative 5x plus 9 to the 1st power. I'd have 4 plus 6x to the 1st power. And so ultimately what I would have here is just simply negative 5x plus 9 equals 4 plus 6x. And then I could solve this problem pretty easily. By just simply getting the x's on the same side. I think probably what I will do here is, how about let's keep it positive and let's add 5x and put it over there with the 6x. And if I'm doing that, let's subtract the 4 and put the 4 over there. And so then we'd end up with just 5 on the left. We'd end up with 11 on the right. Divide both sides by 11. And now I get 5/11ths. Move you out of the way. We get 5/11ths there for our answer. Now it's time to check our work, right? So to check our work, I'm just going to grab my calculator. And you probably can't see that all that well. This is what I did. See how the original problem says negative 5x plus 9 raised to the 1/4 power? That's exactly what I just did here in this first line. Let me highlight it here for you. That was this line right here. I took the negative 5 x, which in my solution was 5/11, plus 9, raise it to the 1/4 power. Instead of using a fraction right 1/4, I just put 0.25. See the decimal I got? That's me doing this side right here. Okay? Then, on my next line, I just did that. And if this really was a good answer, 5/11 is really the correct answer, look at the decimals. They're identical, which means this answer does check out. Okay? Now, as I kept on saying multiple times here, this is the way the textbook wants you to do it. But let me just propose a hypothetical here to everybody in this room that's watching this video or at home watching this video. Suppose I gave you this little riddle here. X to the 7th is equal to 5 to the 7th power. And I asked you to solve for x. How long would it take you to figure out that x has no choice but to be 5? It has to be 5, doesn't it? Because they're being raised to the same exponent, the only way these things could actually ever be equivalent is if that number right there, that unknown number, is the same as that known number of 5. So the point I'm trying to make is if the exponents are the same, then the bases have to be the same. Okay? So if we're looking at, say, b over here, and notice, are the exponents the same? Are they both 1/2? Yes. Yes, they are. So wouldn't this right here have to be a true statement? Wouldn't 7x have to be equal to 5x plus 2? That's essentially what just happened over here on this side of this problem with part A. Since they're being both raised to the 1/4 power, then the parentheses groups have to be equivalent. In other words, the bases must be equal. Okay? And that's what I kind of have hidden right here for everyone to see. If the bases are being raised to the same exponent, then the bases must be equal. You're going to see this when I come back and work with you guys with logarithms in chapter 7. I'm going to repeat this same message to you. If the bases are the same, then if the exponents are the same, then the bases have to be equal. Okay? And then back over here on B, you could solve that problem algebraically and check your work the exact same way. Okay?